Digital recording. All right. So functions, there's a function t. It's t squared minus t plus 6. I don't know what it means. Well, actually I do. Okay, you don't know what it means. So what? That's a function of t. We usually put a t in here when it stands for time. By the way, is time discrete or continuous? Always. Just like speed, just like acceleration, they have to do with time, right? Always, always continuous. So there's a function of t. Either we're going to say, here's the time, find out what this value of the function is, right? If I said t is 4, that's the same thing as saying, well, what's f of 4? I plug in 4 here, I plug in 4 there, and I get the value of the function if time was, I don't know, 4 seconds, 4 hours, I don't know what it is. You don't have units yet. Okay, or we're going to say f of t is, 68 seconds. That's what the function is, and then you solve for the value of t. Now this thing's a quadratic. You don't know how to do that yet. Okay? That's one of two things. Yesterday it was just all this stuff. It was all abstract, right? F of x, what's f of 2, right? Or this function values 24, find x. Now we're going to get a practical example. A candle. There's the function for a candle. Okay? Guess what H stands for? Blah, 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 blah. Oh, look. Height. You guessed before you saw that, or did you see that then guess? Because one way's okay, the other way's cheating. Whatever. Height, it tells us, okay? This is a function of t. Guess what t stands for? Time in hours. Okay? Now, some of you guys, do you know what a candle is? Oh, you do? Oh, good. So this would be a little easier. All right. Common sense says if you don't light it, its height probably isn't going to change. And Calvin's going to say, well, hey, what if you leave it in the sun?
I was actually just...
So I beat you to it. All right. Right? Common sense says if you light the thing and you burn it for a long enough period of time, what happens to the height? Not just smaller. Eventually it's going to get to 0, isn't it? It's going to burn all up. And if you're young enough, you might say something like, where'd go? Right? What happened? At least my kid. Okay? So, there's our function. It's for a candle. We can find values of t, plug it in, and I can go, what is h of t? What is h of 2? What is h of, 4 in hours, and find out what is the height after a certain period of time of lighting it. Okay? Some candles last longer than others, depends on its quality, right? Or I could say, well, let me go and say, when this thing is new, I'm not sure, but maybe at some point later, I want to know when this thing is 8. Do we have the units of height? Yes, we do, in centimeters. When is this thing 8 centimeters? And then you work backwards and you find out what t is. At what time is it going to be 8 centimeters after burning? Okay? So, practical example. Now, graphing calculator. Most of us don't have one. Quickly it says to do this, so I'll just show you what this thing's going to look like. Okay? There's my function. Minus 2. I don't want to put a t. X. The calculator doesn't know the difference. Okay? It's just a variable, right? So minus 2x plus 12. Graph. There it is. Okay? But remember, what is my x-axis? What's my independence? What's my inputs here? Hours. Why do they have it like this? Does negative hours make any sense? No, it doesn't, right? So I can actually adjust this. I can go I just want to go to -1, right? Okay, height. That's this, right? This is h of t. Y-axis, you want to think of that? That's great. That's my output. The height is dependent upon how long I burn it for, right? Okay? This is the dependent. This is the independent. This is the outputs. This is the range. There's another word, right? This is the domain. All right, so my point is, do I want negative height? Like if I keep burning this thing, what? It just all of a sudden starts growing underneath the table? Does that make any sense? No, right? Okay, so I don't want to go and have any negative y's. So that's kind of more relevant to what this graph looks like, okay? I can't quite see the top there. I got to make this thing a bit bigger. No, it's even bigger still. Hang on. X, oh, that's the wrong one. What am I doing? 10, I want to go bigger for y. Let's go up to 15. There it is. Okay? Does that kind of make sense? First of all, is it a linear relationship? Yeah, what other kinds are you guys going to get? That's it. It's linear. Let's think about this. This is the time. Like I said, common sense says when time is 0, that's when the height is as big as it's going to get, right? It's new. I just bought it. I haven't lit it yet. What is that height? We're going to figure that out. As this thing burns, it burns linearly. Sometime later, it's this high. Sometime later, it's that high. Sometime later, it's there. Right there, the t-intercept, do you know what that means? What's the height there? All gone. All gone. Okay, no more. It's burnt out. No more candle. Okay? It's a linear relationship. Okay. So, what does this say? H of 5. Just like we did before, maybe it was f of 2. I took that 2 and I plugged it in whenever there was an x. Now it's not an x, it's a t. Okay? So h of 5, t is 5. That's what I do. I substitute it when there is a t. Just like that. Okay, what is negative 10 plus 2? It's 2. Okay, that's the value of h5. That's all we did yesterday. Now it has meaning. What does this mean in English? What does h5 mean? This is where t was, right? So what does this 5 mean? 1, 2, 3, 4, 5 hours, right? T was in hours. That's what it means. At 5 hours, what? I got 2. What does that mean? It's 2 centimeters tall. That's the height. Okay? This is the height. At 5 hours, it is 2 centimeters high. Okay? It got burnt. Now it's down to this high. Okay? I don't know if this is actually accurate, but that's pretty much what is going on. Okay? Is it okay to make this a solid line? Do you think this is continuous? Or is this a magical candle and it's some height, and all of a sudden, an hour later, it gets to like there? Or does it slowly burn down continuously? Yeah, that's why it makes sense to draw this as a straight line, right? I can always cut this time into a fraction of an hour, a second, a hundredth of a second, whatever, and measure its corresponding height, right? At every single possible time. Okay, evaluate the following and explain their meaning. Significance, whatever. H is 0. That means time is 0. What is H is 0? Plug it in, just like we did before. And anything times 0 is 0. So H is 0 is 12. What does that mean? times 0. That's right when I lit the candle. How tall is this candle new? 12 centimeters. That's the meaning. That's what it means. Okay? So candle is 12 centimeters high. This is height, right? New, or when bought, or before lit. Doesn't have to be new. You could own it for like 8 years but never light it. It's still 12 centimeters tall, right? Until Calvin puts it in the sun. And it's like Frosty. He's gone. And kids cry, right? Okay? All right, h is 6. Well, same thing. Let's substitute that 6 in the equation. Minus 2 times 6 plus 12. That's minus 12 plus 12. What's 12? Take away 12? Nothing. What's the significance there? What does this say? At 6 hours, yeah, the height is 0. The candle height is 0. What's another way to word that in common sense language? What can we say about that? Calvin, sorry? Yeah. How long does a candle last? 6 hours. Okay? You could burn it to actually see. Of course, it varies on the science person in me says, well, what's the wind conditions like? How hot is it out? What's the oxygen content in that air you're burning it in? Okay? It's lots of factors, right? Do you actually cut the wick down each hour, or do you just let it go? Okay? But this thing lasts 6 hours. Hey, companies will advertise that, right? Here's a candle, $6, lasts 6 hours. Hey, a 20-hour candle? Well, that's a little more money. Can you afford that type? Huh? All right? That's the significance. There's that point right here. So I know this is 6. Okay? At 6 hours, the height is 0. Is that called an intercept? Yeah. What happens at the t-intercept, guys? H is 0. Have you ever heard that before? Okay, and h of 8, well, okay, let's look at this last one. Let's put it up here. H of 8. For this example, that's minus 2 times 8 plus 12. First of all, are we thinking, if it burns out at 6 hours, what's going to be happening at 8 hours? Yeah, that makes a lot of common sense. The height is -4. Does that make any sense? Like I said, we don't just burn this thing. Okay, this isn't David Copperfield's candle, and it starts reappearing underneath the table, and now it's -4 centimeters tall. Doesn't make any sense at all, right? Okay? No sense. That's the significance of this. Doesn't make any sense. Okay? Once it gets to 0, it's gone. There's no negatives here. Okay? So that is, we're telling you what the time is, you substituting it in the equation. Do you see how this one is different? How long will it take to burn down to a height of 7? I don't know what t is. That's the value of this function, right? What was it again? Minus 2t plus 12, okay? There's only one of two things we can do, right? We can give you the value of x and say find the value of the function, or we give you the value of the function and say find x. This is the latter. I'm telling you what the height is, okay? We want to solve this for t. See the difference? You need to, okay? All right, so how do I solve that? Well, 7 is minus 2t plus 12. I want to solve that for t. That's our little typical two-step equation. Got to get rid of the -2. Got to get rid of the 12. Which one's easier? It doesn't matter which order it is, but always, always get rid of the plus or the minus first, okay? The opposite of plus 12 is minus 12. It's gone. Okay, 7 take away 12 is minus 5 equals 2t. That says 2 times t. What's the opposite of times, Leon? Oh, yeah, thank you. Divide away the negative 2. Okay? And would have I realized that was wrong? Yeah, because this way times positive. If I would have got a negative time, I would have stopped myself and went, huh? That doesn't make any sense, right? So how many times does 2 go into 5? It's 2.5 hours. That makes more sense in this question. But like I was telling some of you, in this chapter, if you're getting a fraction, leave it as a fraction. It'll make more sense later, okay? When you're solving for the intercepts, don't make it decimals. Leave it as fractions. Okay? That's when it burns down to a height of 7 centimeters. I could graph that. 1, 2.5. That would be 7. That would be the point right there. Okay? If I had nice, accurate graph paper, it would line up perfectly. Okay?
So watching on the X-Berry, you would want us to leave it 5/2.
Yes. Yep. Well, okay, on this question, that's the same number, isn't it? 5/2 is 2.5. Most of us will say 2.5 hours, right? Who goes baking cookies and says, I need 5/2 cups of flour? Not many people, right? So in this question, 2.5 makes more sense, right? Everyone says 2.5 hours. Nobody says, 7/8 of an hour. You don't say that, right? You don't say, well, some people do say 3/4 of an hour, I guess, right? You don't say 0.75 hours. Probably go 3/4. See, it depends, right? Our language is weird, right? Nobody would say this candle burned for 5/2 hours, okay, to get to 7 centimeters high. We would say 2.5 hours. Okay, lastly, hey, look at that, domain and range. Does this go on forever and ever and ever? Or does it just go from here to here? That's it. Domain, it's not x, it's t, but it's always the independent. It's always this horizontal thing. It goes from here to there. That's it. What are those two numbers? 0 and 6. Okay? From there to there. That's the domain. How do I write that? X, t, yeah, is less than or equal to and greater than or equal to. You just got to pick and choose what two numbers go where. It's greater than 0, but it could be equal to 0 too, right? And it's less than or equal to 6. Okay? And we could actually put units on this, couldn't we? 6 hours. We know what t is. The range is the height of the candle. That goes from here to there. Okay? How high is this thing when we bought it? I didn't put that on my graph. Yeah, that was 12 centimeters tall. And if we burn it down to nothing, it's 0. That's the range. Okay? So the height is less than or equal to 12, greater than or equal to 0. Then what little thing do we got to add here? Sure. Okay, yeah, but yeah, where h is all real. Okay, it's not discrete. It's not just integers. It doesn't jump from 12 centimeters to 10 centimeters, right? It's not time-lapse photography. Same thing with t. All real. Okay, so not too much today. 1A says graph it with a graphing calc. You know what? I'll write that for you, okay? If you got one, great. Put it in. But let's just make the picture here, okay? We got an ivory in this school. Okay, this is a plant. Yeah, that's it. Okay, I just want to draw the graph for you. Think, it's a plant. Do they get bigger as time goes on, or is it like my wife and they die and the graph looks like that? I think this example, it's going to start at some height and grow. Okay, so just draw that. You guys don't have a graphing calculator, so just do that. Okay, that's what that graph's going to look like. And for number 2, This is a cost of graphing calculators. How ironic, okay? Here's the function. It's going to look like this. Also, same thing, okay? Sketch the graph. There it is. All right, so if you didn't do the quiz yesterday, grab a board. When you're done, we'll hand them back, and then I'll say some more about it. So Mariah over there, Nikita, Taylor. Julian. Mariah.